Let's look at some solutions to problems. Problem 1. Write the equation of the line that has a slope of 2/3 and passes through the particular point -6, 4. In this case here, for the solution, we're going to use that same point slope formula and substituting m equals 2/3, and for x1 and y1, -6 and 4, we can simplify this to y equals 2/3 x plus 8. Problem 2. Write the equation of the line that passes through the 2 points, 2, 5 and 5, 2. In this case here, we must calculate the slope first because we're not given the slope. Using our slope formula, we see that we arrive at a slope of m equals -1. Using m equals -1 and picking either one of the points, substituting that into the point slope formula and simplifying, we get y equals -x plus 7. Example 3. Find the x and y intercepts for the linear equation y equals -3x plus 3. Finding the intercepts is a convenient way of graphing. First, let x equals 0, substitute x equals 0, which gives us y equals 3. The point 0, 3 is the y-intercept. Then let y equals 0, substitute y equals 0 into the equation. That gives us the point x equals 1. The point 1, 0 is the x-intercept. If you plot both of those points, 0, 3 and 1, 0, on the Cartesian plane and connect them with a straight edge, you'll get a representation of the graph of that line. Example 4. Use that same method of finding the intercepts to graph the line y equals -2x minus 2. First, let x equals 0. That gives us the y-intercept, 0, -2. Then let y equals 0, which gives us the x-intercept of -1, 0. Plot those 2 points, 0, -2, and -1, 0, on the Cartesian plane. Connect them with a straight edge, and once again you have a convenient way of graphing easily a linear equation. Problem 5. Depreciation. This is linear depreciation. A piece of equipment used in a landfill has an original value of $50,000, and in t equals 5 years, the piece of equipment has a value of $25,000. We can use our slope formula to calculate the rate of depreciation, which turns out to be -$5,000 per year. Since the slope is -$5,000 and the original value of the piece of equipment is $50,000, the value equation is equal to -5,000t plus 50,000, where t is the time in years. We can find the value of the piece of equipment at any time t by substituting a value of t into the equation. What would the value of the piece of equipment be in t equals 8 years? Substituting t equals 8 into that value formula, we see that we end up with a value of $10,000. So when t equals 8 years, the piece of equipment will have a value of $10,000. Next question, how many years will it take for the piece of equipment to be worth $0? In this case, we take a slightly different approach and we set the value v in the equation equal to 0, and we solve for t. Manipulating the equation by adding 50,000 to both sides and dividing by 5, we see that in 10 years the piece of equipment will have a value of $0. Problem 6. Supply and demand. A new app is being developed by a cell phone manufacturer. When the price of an app is $8.60, the demand is 14,000 units, and when the price drops to $6.60, the demand increases to 18,000 units. Using our linear formula, we can come up with an equation of D of P is equal to negative 2P plus 31.2. In a similar fashion, the information about supply is given. The price of the app is $5. The company is willing to manufacture 12,000 units, and when the price increases to $7.50, the company is willing to manufacture 16,000 units. Using this information in a similar fashion, we can come up with a supply equation of S of P is equal to 1.6P plus 4. When we set the two equations equal to each other, D of P equals S of P, we get an approximate equilibrium point of 7.56 and 16.09. That is, at approximately $7.56, an equilibrium of approximately 16.09 thousand units. In looking at the graph on the next page, we see that the demand and supply are graphed on the vertical axes, and on the x-axis the price in dollars is graphed. The last part of this question is, when the price of a unit is $10, is there a shortage or a surplus? And by how much is that? We can see from the area where $10 is located that in that case the supply is greater than the demand. When the supply is greater than the demand, we see that there's going to be a surplus. And subtracting the two values of 1.610 plus 4 minus negative 2 times 10 plus 31.2 gives us a surplus of approximately 8.8 thousand units.